I'm Stephen Finucane. I'm an OpenStack developer working for Red Hat with a focus on Nova, and I also tinker with a couple of other projects. And today I want to give a little bit of information about the real-time features that are available in recent versions of OpenStack Nova. So to start, a little bit of not-so-ancient history, what's happened to basically get us to the point that we can talk about real-time in OpenStack Nova. So up until Okada, there was a couple of features that have gone in what Intel call EPA, which is Enhanced Platform Awareness. I don't know what Red Hat's term is. I've worked on some of these. So things like NUMA policies, CPU pinning policies, thread policies, huge pages, SRIOV. If you're coming from a telco background, you've probably heard of every one of these, and you'll probably sick to death of them. But the things that we're concerned about from a real-time perspective are two things that got recently added in the Pike and Okada releases respectively, which are the real-time policy and the Emulator Threads policy. I'm only going to focus on the first of these today because the second one warrants its own lightning talk. So prerequisites. The way I've structured this is I want to give a little example of how you'd actually go about using real-time in the cloud and let people take it from there. So things that you're going to need if you actually want to build your first real-time cloud. You need a recent version of Pike, hardware that's capable of running that. This is probably going to be like a standard Intel like x86 server with enough RAM and decent enough like CPU and power. You're also going to need a recent version of libvirt and a recent version of QEMU, and naturally enough, you're going to need access to real-time kernel sources. So when I was working through this, I was using CentOS. You can also use RHEL, and I'm pretty sure that you could use Fedora as well. I can't speak about like Ubuntu or any of the Debian variants. In terms of the actual hardware configuration, what you're looking to do for real-time is the same thing that you would be doing if you were benchmarking your platform. So you want to turn off basically a lot of Intel's goodness around areas such as like performance or power tuning and that, mostly because these can have adverse effects on your performance, and you want 100% performance at 100% of the time, even if that consumes more power. So things like disable advanced power management, disable hyperthreading because it can give varying results in performance, and things like turbo boost as well. Kill them all. You need, we said this before, you need a real-time kernel. You also need a real-time KVM module on the host. These are all packaged in CentOS and RHEL, and you can build them yourself from source if necessary. And then I'll go through this in a moment, but there's profiles available using the tuned utility, which will basically do all of the complex stuff in terms of like grub configuration and that, so you can just go around to using your platform without having to do this. Doing it manually can be quite time-consuming and difficult to like diagnose any issues if you have them. So an example of what that actually looks like. This doesn't matter, really. The key things here are that I'm installing like a real-time kernel and the KVM module. I'm enabling that real-time profile. This is all done for you. The work has been put in the recent years to let this happen. And then huge pages are a pretty useful thing to enable from like improve your determinism of your guest and the host. So enabling huge pages. And then you want an instance which is going to be almost the exact same as your host. Again, there's tuned profiles available for this. Use those as you can. You're using the guest tuned profiles. You also need to use the same real-time kernel. So the CentOS, I use CentOS in my case, the CentOS kernel, which is packaged upstream and just involves enabling a repo. And obviously, if you already have an application that you want to test, then use that away. I just went with standard Linux. And it looks basically the exact same. The configuration steps, nothing too complicated there. Once you now have your configured host, you have your configured image. The last step for this is to enable a flavor that you can use, like a real-time flavor. There's 4 things necessary. You need to enable your dedicated CPU policy, which will ensure that your guest CPUs are pinned directly onto your host CPUs. Standard things apply here. So for example, you don't want to mix unpinned instances with pinned instances because the unpinned ones will stomp over your pinned instances. Enable real-time policy. Enable a real-time mask, which is you need this for the Linux kernel. Linux can't run 100% real-time because there's like overhead tasks. So you need to set aside some cores that the scheduler can do all of its like non-real-time functionality on. And then enable huge pages. And then after that, you just boot your instance, basically. The points I'm trying to show here is that everything is packaged up. If you're using a RHEL distro or some other base OS that has all of these things available for you, it's a case of installing a couple of dependencies, configuring a few extra specs, configuring image metadata properties, and literally booting an instance. You do this, you can go into your guest application, you can start whatever benchmarking utility you want, and you should be getting latencies, in my own experiments, of like less than 20 microseconds, which is exactly what we'd be looking for on the kind of hardware that we're dealing with. One other thing that's worth mentioning, I said about emulator thread policies at the beginning. If you're using QEMU and KVM, because this is only QEMU, KVM, this isn't available for Hyper-V or anything that I'm aware of at the moment. QEMU has overhead threads that it needs to do for things like disk I/O and that kind of thing. There's a thing that's worth looking into, which is emulator threads, which will allow you to offload all of those to a specific CPU and make sure that, again, that they don't go stomping over your real-time CPUs. I'm not going to go into that because I've been told to talk really quickly because we're behind. So, based on that, any questions? Anything I can double back over? At the back.
Is there an IRC channel or a Slack chat that we can go to discuss this and find more information about this kind of stuff?
Yep. So the best forum for this, because it's a Nova feature, is pop up on OpenStack Nova and look for. Hold on, I'll go all the way back to the very beginning. I don't have my IRC, so it's Stephen Finn. I'm on IRC. Ping me on that. Red Hat also, this is available as a tech preview in recent versions of OSP. So there's Red Hat documentation available for using that as well. And there's documentation in the Nova docs as well for this too. Yep. Yep.
One big problem we always have with, we tend to deal with carrier values, right? The biggest issue we have is tuning to 10, 25 gigabit NIC cards.
Yep.
And the way that they do PCI, IRQ reservation. Quite often what will happen is that they'll reserve the cores of the NIC cards and not for IRQ and use it to split it up into over instance compute. So we have to be really careful about tuning them. How does this affect the IRQ allocation of hyperclusters with the real-time kernel? I've never run a real-time kernel on Nova instance, so I'm just wondering more.
So I'm not sure if it's completely applicable. So one big issue that we're aware of in Nova at the moment, I don't know if this is the same thing. If you're using a DPDK NIC, yeah, okay. So that's got, because it's a NIC, it's got memory that's mapped or DMI or whatever, and that's fine to certain NUMA cores. Yeah. So we completely separate from this, but we have specs aimed. They missed this cycle, they're aimed for the next cycle to start communicating between Neutron and Nova and passing NUMA information back to Nova. At the moment, the only viable workaround for this is to use just cores of or just to have like single socket CPUs and disable the other one entirely to get. Otherwise, you're going to have the exact same performance with real-time as you would with non-real-time instances. Anything else? Yep. Thank you very much.